Hi, I'm Jeff Ranasinger, VFX Supervisor and Director, and I'm here to talk about Deep Image Workflow. The clip that is playing has elements that are in front, behind, and through one another. All elements were rendered as separate layers and combined using Deep Combine. It's important to note that no matting was used in these layers. Instead, Deep Image Workflow takes care of the combining for me. So let's take a look at how this was put together. First of all, we have the liquid simulation over a background. The ROPs for the mantras are in pale blue, whereas the fluid flip simulation is in red and the meshing is in yellow. Note that they're chained in this way not to facilitate data flow, but instead to manage dependencies. The simulation needs to take place before the meshing, which in turn needs to take place before the mantra rendering. On the mantra ROP, under Deep Output, Deep Camera Map should be selected as a deep resolver. Then I connect the mantra straight into the DSM merge. This will handle the dependencies. If we look at the DCM merge, you can see that there's an output. This output is going to be the combined deep image. So at this point, the intent would be to combine the sky and the liquid simulation. I'm going to take the file name for the deep image of the sky and paste that down here as a reference. Now, as you can see, that reference is a simplified path because I used relative reference. The one for the fluid is similar, so I'm actually just going to copy that and paste that, adjusting the element name. The output of this DSM merge is another deep file, which is the combination of its source deep files. I then want to convert this deep file to a flat EXR, and to do this, I use a comp node. I point it at a COPS network, and inside this COPS network, I put down a file node. This file node is set to read the DSM merge's merged output. I set the output file for the composite node, and then plug that node into the new FFmpeg. This allows me to generate movies directly on GridMarkets. I click Fetch Image and Set Movie, and then set the movie codec to H.264. Make sure that it's set to linear, because EXRs are typically linear. And then finally, connect this to my GridMarkets render submit. I then connect the two mantras to the render submit, because I want to make us aware that I want to download the images that the mantras create, as well as the H.264. Then I hit submit. So that gets me this, which is essentially like an A over B with the fluid sim over the background. But I'm going to add a new element. This time a cube that is centered around the simulation. I'm going to do exactly the same as before. I'm going to plug that into the DSM merge and also into the render submit for exactly the same reason, to get the images and to pipe it through the FFmpeg. I'll drop in a new source. I'm not even going to bother finding it. I know that it's going to be the same syntax, just with a different element name, so I copy that in and change it manually. I bypassed the previous renders because I already have their data on the cloud, so my current setup is the original deep files going through the DSM merge, as well as the new deep files generated by the new mantra. These in turn go through the same flattening process, the FFmpeg, culminating in new renders and a movie to represent them. So I'll submit this and let's take a look at the result. As you can see, the cube and the existing fluid sim exist properly in space. But let's look at what would have happened if we'd done it with a regular A over B comp with no matting. As you can see, what should have been behind the liquid simulation is in fact in front. But with deeps, this is automatically taken care of. Now this would have been a very simple matting exercise, but it's one less thing to think about. So let's go further with this and add a pyrosim. I have my simulation step in red. I'm going to make a smoky element that's rendered through this mantra, plug that into the DSM merge and into the render submit. and add it as a source in the DSM merge in exactly the same way as I have done before, copying and pasting a link from another element and then changing the element name. The render will be passed through the DSM merge with the existing deep files, combined, flattened, and then turned into a new H.264 movie. So let's submit that. Here's the result. As you can see, the smoke simulation has rendered and is correctly placed in front of and behind the existing elements. Doing another comparison of A over B versus deep merging, we can see that variable transparency, like the smoke, is handled properly in depth. So again, I'm going to bypass the existing successful renders and move on for a new element. This time I'm going to advect some points through the pre-existing smoke simulation and then connect those points. These steps follow one after another, and after that is a mantra node. Note how I make them dependent so that if I was to run the whole thing again from fresh, the advection would happen after the smoke simulation. Add the new element as a source in the DSM merge. Make sure that everything I don't need has been bypassed, and then submit. This is the result. So now things are getting quite complicated. But again, no mats are used and things are correctly placed in depth. So let's take a close look at this and compare the results of deep compositing with the regular A over B. As you can see, with deeps, things are correctly positioned and including other items, whereas without, things just obviously lie on top of each other. A nice thing to note is that the advected element is correctly positioned inside the smoke. That is to say, it emerges through the smoke based on the smoke's opacity. So let's round this off with one more element that acts as a kind of frame for the composition. I'm going to make it dependent on the advection and the original liquid sim, just in case I need to run it all again in the future, and because I'm going to use some reflections in this item. Again, this is an item that exists in front of and behind the other elements. With regular compositing A over B, the problem is really clear. Unless you have matting, there's no way of isolating what should be in front of it and what should be behind it. But with deeps, this isn't a concern whatsoever. I hope this little demonstration shows you what's possible by using deep image workflow, how much time it would save you, and the flexibility that's gained from using it. In addition, I've introduced you to the new FFmpeg node, which allows you to take rendered images and turn them into H.264 or ProRes movies. It might also be useful for you to note that this FFmpeg node does not require using deep workflow. You can use it on any output that gives you EXRs. Thank you very much for watching. I hope this has been interesting and helpful. Please feel free to contact me or anyone in the GridMarkets team if you have any questions.